All right, so we're going to look at another one that is a law of sines problem with the angle side ambiguous case issues. For this problem, we know that angle A is still 30 degrees, side length B is still 16, but now A is going to be length 10. So if you watch the other video, the only difference is that this side length's changed, and it's going to make a world of difference. On the first video that I'm referring to, A was only 7 and it resulted in no solution. The triangle was impossible to build. But again, you won't necessarily know that it's impossible or possible when you start. So you'll just doodle a triangle. You'll have no clue how close to correct your doodle is. And let's say you know that this is angle A and you're drawing and you know that it's 30 degrees. And the side length opposite it is 10. And let's say this time, so that it's similar to the other one, I think I put angle B up here. And so this is going to be 16. And so this has to be angle C, and this is side length little c. And so the way these problems work is, you think about law of sines, and you're given like a pair of an angle on this corresponding side, in this case A, and then you have to be given either the angle or the side for one of the pairs. So you got to think about what you're given. So in this problem, we're given angle A and side length A and side length B. So we're going to use these two parts from law of sines. We're going to say that sine of 30 degrees is to 10 as sine of some angle is to some side length. We know side length B is 16, so if we use 16 here, that means we're going to be finding angle B. From there, it's mostly a calculator problem. You would make sure you're in degrees, and you would get 0.05 for this side, and that's actually exact. Bonus would equal sine of B. Pretend I can draw. I can't do it. Let's rewrite that B. That's a lot better. Divide by 16. You would multiply the 16 to the other side, and you would get 0.8. And that's fine. It is between -1 and 1, so it's not like the other example where it won't be possible. But like the other example, we're trying to find an angle. So we're going to use inverse sine on the calculator to look up the angle that would have a sine of 0.8. And it's about 53.13 degrees. So, my drawing is really far off. I had B as being kind of obtuse in my drawing, but it's really 53 degrees. That's okay. The drawing was just to help us think through the problem. Because we have figured out that B is 53.13 degrees, we can use that to find angle C. We know the triangle is 180 degrees, so we can find angle C. It would be 180 degrees, subtract the 30, subtract the 53.13. 180 subtract 83.13 is 96.87 degrees. And technically this is still an approximation because we approximated angle B. So now we could work law of sines using angle A and side length A and this angle C that we figured out. So we would copy, so to speak, this part that we just used and have 0. That's a terrible 0. I have 0.05. Again, we would just do this same work, but this time, instead of being equal to sine of b out of 16, it's going to be equal to sine of angle C, which is 96.87 degrees, out of the side length that we don't know. And so we would multiply C to this side, running out of space. And we would grab our calculator and we would do sine of 96.87. It's an angle, so it's just regular sine. And that's 0.993. Remember, sine can only go up as high as 1, so that's, it's almost 1. 9. Tell you what, I'm going to keep 4 decimal places, 28. And then we would divide that by 0.05. So I'm just going to actually use the decimal on the screen and hit divide by 0.05. That's 19.86 rounded to 2 decimal places. So we used law of sines, this part, and found angle B. Used angle B, now that we know all three, 2 of the angles in the triangle, to figure out a third angle in the triangle. Knowing that angle and reworking law of sines, a different problem, let us figure out the missing length. So now we actually know that you could build this triangle, and this would be the other 2 angles, and this would be the third side that hadn't been mentioned. But because it's angle side side, we have to be careful. Because with angle side side, here's what can happen. That line isn't straight. And the drawing, I was going to make an effort. The triangle could look like this, but if this is the missing side that we don't know, it could be that that missing side, instead of looking like that, looks more like this. It could be that it's sort of been swung over here and still completes the triangle. So sometimes there are 2 solutions, and you have to figure out if there are 2 solutions. To decide if there might be two solutions, you go back to this step right here. And you check something. So I need to remember that it's 53.13 degrees. So what if instead of being 53 point, I think it was 18, what if it's this way? What if it's an obtuse angle? And this goes back to the idea that thought bubble time, when you're thinking about trig in the coordinate plane, this y coordinate would be the same as that y coordinate. And you don't actually know whether it's the 53 degrees or that it's over here, in which case it would be 180 subtract 53 point, was it 13? 13. It might be that it's an obtuse angle instead. The calculator doesn't know. It doesn't provide both. You have to know enough to go check and see if it's could be the other one. In this case, the other angle would be 126.87 degrees. So if you check on your calculator, if you do sine of 126.87, that's 0.7 and then a whole bunch of nines and then an 8928. And if you check sine of 53.13, you get the same decimal. That's why there might be two solutions. There's no way to know whether that angle is 53.13 or 126.87 until you start trying to consider, well, what happens if it is the 180, subtract that answer? What if it's that angle? What if it's over here in some kind of like really obtuse triangle instead? So we start considering, well, what if B was 126.87 degrees instead? And we got to rework the problem from here and see if it causes an issue. Well, this angle here was 30. Angle A was 30. And we're considering whether or not it's okay if angle B is 126.87, which would give us a different value for the number of degrees for angle C as a minute ago. Like a minute ago, C was obtuse, it's 96.87. Now it's going to be some little acute angle. So it'd be 180 for the triangle, subtract 126.87 and 30, or 156.87. So it could be that C, instead of being an obtuse angle, maybe angle C is acute because B is obtuse, in which case it would be 23.13 degrees. And a minute ago, A was 10 and B was 16. So these are still 10 and 16. But if C is now an acute angle, this side over here is not going to be nearly as long as it was a minute ago. A minute ago, it was almost 20. But we've made the angle so much smaller that the side across from it has to get smaller too. We just got to see if it's a possibility. And so we go back again to this blue work that I boxed in right here. We're going to copy that 0.05. It's these two steps. We get to use those again. And we want to know, a minute ago, It was the sine of the 96.87 in ratio to C. So now we're going to use 23.13 instead and see if it works. If it works, we've actually found two different triangles that match these initial conditions. On the other video, there wasn't a triangle that matched the initial conditions. On a lot of the examples we did in class together, there was just one triangle that matched the initial conditions. This video is about the fact that maybe it's two. And this would only happen in that ambiguous case. That's why it's called the ambiguous case. That's when bad things happen. So we multiply the C over. We would grab a calculator and get a decimal for sine of 23.13. Excuse the writing, it ain't great. That decimal is about 0.3928. So 0.05 times some number equals this decimal. We would divide by 0.05, just like I said it on the other one, but I didn't have room to write it. And again, I'm just going to divide the decimal on the calculator screen by 0.05. And you get 7 point, rounded to two decimal places, 86. So we have found another triangle. It could have been that B was, instead of 53.13, it could have been that it was 126.87. There's no way to know. In which case, now angle C is a tiny little acute angle, and C is a much shorter side. So there are actually two possible triangles for these initial conditions. And there's only going to be one or two of these in the homework where you end up realizing that there could be two. And so to watch for it, when you get this first angle and you know that it's an angle side angle problem, after you solve it the first time, go look at what happens if you start at 180 and subtract that angle and you get this new angle and you try to work the rest of the problem with that angle instead. Do you still get answers? Then there were two answers. There were two solutions for the triangle. I hope this helps some. This is probably one of the trickier things you'll see in this class. It's definitely one of the trickier things with the trigonometry. Bye for now.